Okay, so we're going to do the Lewis structure for bromine monochloride. So that means I have one bromine and I have one chlorine. All right, I'm going to look on the periodic table to see how many valence electrons they have. So here's chlorine and here's bromine. They're both in group 17. So they both have 1, 2, 3, 4, 5, 6, 7 valence electrons. In fact, it's going to look exactly like if I had the F2, all right, because they all bond the same, because they have the same outer electrons. So let's draw that in. So I've got seven valence electrons for bromine, and then I have 7 valence electrons for chlorine. And that means I have lone pair, lone pair, lone pair, and then I have one bonding electron for the chlorine right here, and I have one bonding electrons for bromine. All right, it also has all the rest are lone pairs, so they're not going to do the bonding. So my covalent bond is going to be right here. I'll have a single covalent bond, and that fulfills the octet rule for bromine and for chlorine. All right, so my Lewis structure is just going to have the symbols right here, the covalent bond in the middle, and then the electrons here. The shape of this would be linear because there's only two elements, so it's going to be a linear shape. And polarity, it would be, it depends on the electronegativity. So I'm going to look at my periodic table, and bromine is in an outer level. It's in the third energy level, and chlorine is in the second energy, or excuse me, this is bromine. It's in the fourth energy level, and chlorine is in the third energy level. So chlorine has higher electronegativity, and bromine has all these electrons in the middle, shielding them from the nucleus. So chlorine is going to be better at pulling the electrons closer, and so that would make this kind of a negative side and this more positive, because the electrons are negative. So you have a polar, linear, covalent bond here, molecule.